Chapter 5, review for the test. Let's start with number 1. Remember, when you read a question, you want to kind of chunk, and because you can write on your test, you can just circle the information. So here it's telling me a force of 80 newtons pushes a 50 kilogram object on a level floor for 8 meters. What's the work done? So for number 1, work is equal to FD. Now, the mass of the problem, you don't need that because they're pushing it across a level floor, so it's being pushed horizontally. So it's just the 80 Newton force times 8 meters comes out to be 640 joules. So the key to this problem is work is only done in the direction in which the object moves. So the weight is acting down, so I do not need the mass, which is given in the problem, and with this, because the weight would be the force of weight acting down, which would be the mass times gravity, but we don't need that. So sometimes they give you information that you don't need. Okay, number 2. It says a 500 Newton girl lifts a 10 Newton box vertically upward a distance of 0.5 meters. What's the work done? So again, we know that work is equal to FD. The only thing that's moving is the 10 Newton box, and it's moving vertically. So the weight of the box, 10 newtons times 0.50 meters is 5 joules. So the girl's mass is not being displaced. Okay, number 3. As shown in the diagram below, a child applies a constant 20 Newton force along the handle of a wagon, which makes an angle of 25 degrees. How much work does the child do in moving the wagon? A horizontal distance of 4. So the child is moving horizontally. It's moving 4 meters. And even though he's pulling with a force of 20, only the horizontal component of that 20 Newton force is doing the work. So the horizontal component here, Fx, we see that that is adjacent to the given angle. So W is equal to FD cosine theta. So it's 20 newtons times cosine of 25 degrees times 4 meters. So for number 3, W comes out to be 72.5, but when I look at my choices, it hasn't the correct significant figures, so it comes out to be 73 joules. So this was 73, so that's D. This number 2 was 5 joules, so that's B. And then number 1 was 640, which was A. Number 4, if 120 joules of work is done in 4 seconds, what is the power? So we know that power is work divided by time. So the work is 20 joules over 4 seconds, and 20 divided by 4 is 5, and a joule per second is a watt. Number 5. If 20, that was number 4, and the answer was A, 5 watts. Number 5. As the time required for a person to run up a flight of stairs increases, the power developed. So we know that power is work divided by time. So now they're asking you, if the time increases, what's happening to the power? So this is going to decrease because we see that these are inversely proportional. So for number 5, the answer is going to be A, decreases. And we can tell by looking at the equation. Number 6, a cart has a mass of 2 kilograms and moves at a constant speed of 4 meters per second. Its kinetic energy is, so for number 6, kinetic energy is 1/2 mv squared. So it's 1/2 of 2 kilograms times 4 meters per second squared. Whoops, the squared is outside. And when I do 4 squared is 16, but 1/2 times 2 cancels out, so it's just going to be 16 joules. And that is right here, 16. So if you forgot to square or something like that, of course, that's going to be one of the choices. Number 7, as an object moves upward at a constant speed, what happens to its kinetic energy? Well, we know that kinetic energy is 1/2 mv squared. So if this is constant, the kinetic energy is going to remain the same. So that's C. Number 8, what is the gravitational potential energy with respect to the surface of the water of a 75 kilogram? So, and this is gravitational potential energy located 3 meters above the water. So for number 8, potential energy is mgh. So it's 75 kilograms times 9.8 meters per second squared times 3 meters. When I put that in my calculator, it comes out to be 2205 joules. And when we look at the significant figures, we have to be able to recognize the correct answer. So in this case, number 8 is B. Now you might look at this and say, oh, they're close. If you look, the exponents are all different. So this is to the first, this is to the fourth, third, and second. So you don't have to worry about, oh, with the significant figure. So this is 2.21 times 10 to the third joules. So the answer here is B. All right, let's look at 9. 10 and 11 and 12 on this side. So for number 9, it says which mass has the greatest potential energy with respect to the floor. So that's my gravitational potential energy, which is mgh. So they're all going to be multiplied times gravity, so I don't even have to bother. So what I'm going to do is just do the mass times the height. So 50 times 0 is going to be 0. 2 times 10 is going to be 20. 10 times 2 is equal to 20. And 6 times 5 is equal to 30. So the answer is going to be D, because that's the greatest 30. Maybe we don't need this other paper. All right. All right, so let's look at number 10. So number 10 says, base your answer to the following question on the diagram, which represents a simple pendulum with a 2 kilogram bob and a length of 10 meters. So they're giving you a lot of information here as far as the positions are concerned. But when you see something like this, it says compared to the sum of the kinetic and potential at 1, what's the sum of the kinetic and potential at 3? Well, with conservation of energy, the total amount of energy remains the same. So the sum of the kinetic and potential will always be the same at any of the points. So there's a lot of verbiage here, but you don't need that. So the answer is just C, the same. All right, number 11. It says a ball is thrown vertically upward. As it rises, its total energy, and it says neglecting friction, is going to remain the same. And again, with conservation of energy. Now, whatever you lose in kinetic, you gain in potential, but the total always remains the same. Okay, number 12. A 20-kilogram object strikes the ground with 1,960 joules of kinetic energy after falling freely from rest. How far above the ground when it was released? So here we're doing conservation of energy. And if you want, you could write the whole equation if you want. So the whole equation for conservation of energy would be KEI plus PEI is equal to KEF plus PEF. But now we have to say to ourselves, well, initially, the kinetic energy is 0, and at the end, when it strikes the ground, the potential, because the ground is going to be base level. So now we see that MGH is equal to, and they told us KEF was 1960 joules. So now I'm going to rearrange the equation because they ask us to solve for H. So H is equal to 1960 joules divided by mg. So it's 1960 joules divided by 20 kilograms times 9.8 meters per second squared. So this comes out to be 10 meters. So remember, if you want to conceptualize the picture, here's the object, and it's falling from rest. So here, the total energy remains the same. So at the top, the potential energy is going to be a maximum, and the kinetic, because it's at rest, is going to be 0, which is a minimum. And right before it hits the ground, the potential energy is going to be 0, because it's just about touching the ground, and then the kinetic energy is going to be a max. All right, let's go to the next set of questions. There's only a few left. All right, so let's look at number 13. So 13 says, base your answer the question on the diagram. So this is a 1 kilogram block being held at rest, so it's not moving. The object's released and slides the length of the incline. The kinetic energy. So this is still conservation of energy. So the total energy here is equal to the total energy at the bottom. So if I wanted to write conservation of energy, remember the bottom of the incline is going to be base level. I would say KEI plus PEI is equal to KEF plus PEF. Now, initially it's at rest, so this initial kinetic energy is 0, okay? And when it's at the ground, this is 0. So MGH is equal to KEF, and it says what's its kinetic energy. So it's just going to be 1 kilogram times 9.8 meters per second squared times 2 meters. And that comes out to be 19.6 joules. And that is choice A. I'll put A up there. All right, now we have a graph for number 14. So it says, which graph best represents the relationship between the gravitational potential energy of a freely falling object and the height above the ground near the surface? So remember, gravitational potential energy is equal to mgh. So as the height increases, so does the gravitational potential energy. They are directly proportional. So when we look at our different graphs, this is not directly proportional. This is a straight line. This shows as the height decreases, as the height increases, the gravitational potential energy decreases, and that's not correct. So that's how we know A is the right answer. So as my height increases, my gravitational potential energy increases. So that shows that they are directly proportional. And we see that just by looking at the equation. All right, last one. So number 15, it says a box is pushed to the right with a varying horizontal force. The graph below represents the relationship between the applied force and the distance the box moves. So it says, what is the total work done? So what we need to know is on an F versus D graph, work is equal to the area under the curve. Now this curve can be a straight line. So the area is going to be this area plus this area. So we have basically a rectangle plus a triangle. So the area of this is going to be base times height plus the triangle, which is 1/2 base times height. So now when we look at it, this is 3 times 6 plus 1/2 of 3 times 6. So 3 times 6 is 18, and then 18 divided by 2 is 9. So my answer comes out, whoops, I'm off the camera, 27. So this is going to be 27 joules. And that is choice A. And that's it. That's going over all the questions. The 15 on the review sheet. And again, you need to do these yourself and make sure that you understand them step by step.